Hello everyone. So in this video we will be dealing with the Python implementation of Monte Carlo control algorithm. So the program demonstrates how to implement the Monte Carlo control algorithm to solve the frozen lake environment. It shows the effectiveness of the algorithm in finding the optimal policy for navigating the grid world as evidenced by the printed output. So the objective of the program is to find the optimal policy for navigating a grid world environment called the frozen lake using the Monte Carlo control algorithm. In this environment, an agent needs to navigate from the starting state to the goal state while avoiding the hold states. So the frozen lake environment consists of states, actions, transition probability, and rewards. The goal is to develop a Python program that implements Monte Carlo control algorithm to find the optimal state for this environment. So the states include 5 terminal states and 11 non-terminal states. Terminal states include the goal state, the state the agent aims to reach, and all the whole states, a whole state that the agent must avoid at all costs. And the non-terminal states include the initial position of the agent, which is the starting state, and all the intermediate states, the grid cells forming a layout that the agent must traverse. And the actions would include 4 possible actions, which is left, down, right, and up. Moving to the transition probability, slippery surface with a 33.3 chance of moving as intended and 66.6 chance of moving in orthogonal directions. For example, if the agent intends to move left, there is a 33.3 chance of moving left and a 33.3 chance of moving down and another 33.3 chance of moving up. And then the agent receives a reward of 1 for reaching the goal state and a reward of 0 for otherwise. So let's get into the algorithm of Monte Carlo control method. At the beginning, the value function v of s and the policy phi of s are initialized with arbitrary values. Then using a current policy, an episode is generated by interacting with the environment, and the sequence of states, actions, and rewards encountered in the episode is stored. Then iterate over each state encountered in the episode. Then we will be calculating the return G from the first occurrence of the state S in the episode. Then update the state value function by averaging the return for state, and then iterate over each state encountered in the episode again. Then we will be updating the policy by selecting the action that maximizes the sum of expected future rewards, considering the transition probabilities to the next state. Then continue to generate the episodes and update the value function and policy until the policy converges. That is, until there are no significant changes in the policy. Then we will be using a function named decay schedule to decay the exploration parameter epsilon and the learning rate alpha over time using decay schedule. Then we will be generating the trajectories, which is nothing but the sequence of states, actions, and reward for the training. Then we will visualize the progress of the algorithm using a progress bar, providing feedback on the number of episodes completed. Once the policy converges, use the argmax function to find the action that maximizes the value function for each state, thereby determining the optimal policy. So this algorithm iteratively improves the policy by learning from the episodes of interaction with the environment, gradually converging towards an optimal policy that maximizes expected rewards. So let's get into the Python implementation. So this function implements Monte Carlo control algorithm to learn an optimal policy for the given environment. So this function implements the Monte Carlo control algorithm. So MC underscore control will be our function name. So here in the arguments we have env, which is the environment object. Then gamma represents the discount factor for future rewards, which is 1 by default. Initial underscore alpha represents the initial learning rate, which is 0.5 by default. Minimum underscore alpha represents the minimum learning rate, which is 0.01 by default. Alpha underscore tk underscore ratio represents the ratio by which to decay the learning rate, and it is 0.5 by default. Initial underscore epsilon represents the initial exploration rate, which is 1 by default. Minimum underscore epsilon represents the minimum exploration rate, which is 0.1 by default. Epsilon underscore decay underscore ratio represents the ratio by which to decay the expiration rate, which is 0.9 by default. N underscore episodes represents the number of episodes for training, which is 3000 by default. Maximum underscore steps represents the maximum number of steps allowed in an episode, which is 200 by default. First underscore visit represents whether to use first visit MC protection, which is true by default. So in the function, we will be having all the initialization part and the episode loop, and finally returning the values. In the initialization part, we will be initializing variables including the number of states, which is ns, and actions, number of actions, which is na. Then queue table, state value function v, and policy pi using default dictionary. Then we will be initializing a lambda function select underscore action for action selection. In the episode loop, we will be iterating over n episodes to train the agent. Then decays the expiration rate epsilon and learning rate alpha based on decay ratio and epsilon number. Then we will be generating a trajectory using the generate underscore trajectory function. Then calculating the returns and updates for Q value and policy, followed by updating Q value and policy for each state action pair using either first visit or every visit MC prediction. Finally, tracking Q values and policy for analysis. Then in the written part, we will be returning the learned Q value, state value function V, and the policy pi. At last, we will be printing the action value function, state value function, and policy obtained from Monte Carlo control algorithm for the given environment. So for the environment being considered in this experiment, the success rate would be 96% and the average discount would be 0.99. So the overall purpose of the program is to find the optimal policy by using Monte Carlo control algorithm. Thank you.